Okay, here is the second part of the notes from lesson 3.7. We skipped examples 3 and 4. All right, so in example 3, we have AB congruent to BC. This is going to be one of those solve type problems. We learned the other day that in a triangle, if the sides are congruent, then the angles opposite them are congruent. So the angles opposite them would be the 72-degree angle and this x squared plus 6x. So since they're congruent, I set them equal to each other. So the geometry part is pretty straightforward. Now I just need to solve. So I'm going to subtract the 72, set it equal to 0 because it's a quadratic. I need to factor. I think it's going to be x plus 12, x minus 6. So that means x is negative 12 or 6. And then it just says solve for x, so I'm done. Okay. And if you check, by the way, negative 12 in here will make this angle positive, so we don't have to worry about the fact that it's a negative value. All right, last one here, proof. CE is congruent to CF. That's these full segments here. Angle F is congruent to angle 3. Angle F and angle 3. And angle E is supplementary to angle 5. All right, well, first thing I notice is that it's a little weird that I have just one supplementary statement. I have angle E supplementary to angle 5. Well, I'm not sure that that tells me much, but I'm looking at 5, and I do know that 5 is definitely supplementary to 4, and I know that because I can see this is a straight angle. So I'm going to go ahead and say that first. I'm going to say angle CGF is a straight angle. That would be assumed. And then I could get a second supplementary statement. I could say angle 4 is supplementary to angle 5. Because if angles add to 180, then supplementary. But now I'm looking at these two right here. They're not right next to each other, so it's kind of hard to box up. But remember, if we could put them in a box, we'd look for something that is congruent or something that is the same. Usually we have congruence, but this time you should notice that you actually have something that is the same. So if these match, I should be able to get E and 4 to match. So angle E congruent to angle 4. I would say if angles sup to, and this time I'm going to say same angle, then they are congruent. So let's mark that. I now have angle E congruent to angle 4. But I'm still stuck. I'm trying to get angle CDG here. I need this guy to be isosceles. So I go back and I look in the given and I think, is there anything I didn't use, right? Well, I haven't used F and 3 congruent yet. I'm not sure how that works. And I haven't used this, CE congruent to CF. Well, if you think about what we learned yesterday, all right, if I could pull it back up here, all right, how do one of these theorems apply? Well, I'm looking at the two segments they gave me congruent, right? That's this segment congruent to this segment. Isn't that this picture right here? So if I have two sides of a triangle congruent, then shouldn't the base angles be congruent? So if those are congruent, I think the two angles opposite those in this triangle are this angle and this angle. So I think I can get, by my new theorem, angle E congruent to angle F. And that would be by if the sides are congruent, these big orange ones in this big triangle here, then the angles are congruent. So now I'm wondering how that helps me. So I want you to look at, let me circle them here, this and this and this, and I hope you can see that we have some connections here, right? I have 3 matches F, but F matches E, and E matches 4. So by transitive, I can get angle 3 congruent to angle 4. I hope you see why that's useful if you're looking ahead, right? If I now can get these two to match, right? This guy and this guy, well, I think that's enough for me to say that CDG is isosceles, because remember we have two different definitions for isosceles. Either the two sides have to be congruent or the two angles have to be congruent, which is what I have. So angle CDG is isosceles. If two angles are congruent, then the triangle is isosceles, and you can use those abbreviations. All right, so that was a little tricky, connecting some things up using transitive.